So today we're going to cover Chapter 4, Section 3C. So today we're going to learn about ellipses. So what we're going to do is learn how to find the different parts. Ellipse, if I go to this next slide, we're going to have ellipses that are horizontal, and we're going to have ellipses that are vertical. So it's going to take on, if it's horizontal, it's going to be, the oval shape will be longer across the x-axis or horizontally, or if it's vertical, it'll be up and down longer. So an ellipse is just the set of all points, x, y, in a plane, that the sum of whose distances from any two distinct points is going to be constant. And that's going to be your foci, or your focus points. So when we're calculating the parts of the ellipse, we're going to be finding vertices, co-vertices, the focus point, and the center point. So here we're going to have an A, B, and a C value. And we're going to see what we're going to have for each one of these parts. So these are both pictures when the center is at the origin. So my center on both of these is at 0, 0, or the origin. Now, plural of foci is going to be focus, and that's what we've been seeing. Each one of these are going to have two foci, or two focus points. In our equation for the horizontal, when the center is at 0, 0, it's going to be x squared over a squared plus y squared over b squared, and it always needs to be equal to 1. Now, in this equation, the a squared is always going to be the larger number. And wherever a squared is located, that's going to tell you where your major axis is, if it's horizontal or vertical. So notice for this one, I put a squared under x squared. So that told me that my major axis is going to be the x-axis, making this horizontal. When a squared is under y squared, so here I'm going to switch it, then this tells me that my ellipse is going to be vertical. So my major axis is going to be up and down vertically. And then the minor axis would be horizontal. The endpoints of my major axis are going to be the vertices. The endpoints of my minor axis are going to be the co-vertices. So this is going to be different from what we've seen before. Now, when we want to find the vertices, I'm going to take my a squared number and I have to square root it. And this is going to give me both positive and negative a. And then if you notice in the picture in red, that's going to give me the order pairs for my vertices. So my vertices, when it's at the end point of the major axis, it'll be a comma 0, negative a comma 0. And we find that a value by square rooting the a squared value. And it's always the bigger one. Then the co-vertices are going to be, they're here in green, but we take the b squared value and we're going to square root that, and that'll give me plus and minus b. And when my graph is horizontal, my co-vertices are going to be the endpoints of the minor axis, and that'll be 0 comma b, 0 comma negative b. The focus points are always going to be on that major axis. They're going to be next to the vertices. And we're going to learn a formula in order to get the c value using your a squared and your b squared. And the formula to find c, sort of like the Pythagorean theorem, but it's c squared equals a squared minus b squared. So you would take these two numbers here, and then you would square them and subtract them, and then square root it to get c. But we're going to see that calculation. So again, the focus points, that's what's going to use c, and that's in blue here. And I would take the c value, that c squared, square root it, and that'll give me my C, which will give me my focus order pairs. So when it's horizontal, it's going to be C comma 0 and negative C comma 0. Now, if you notice when it's vertical, notice the order pairs change. Notice here for the vertex, or the vertices here, notice now it's 0 comma A when it's vertical. And then the co-vertices would have that B value in the X spot. But we're going to see this coming up. So it's going to be a lot of memorization and memorizing all of the formulas and the steps that you need to follow to find all these pieces. So let's go ahead and take a look at the equations again in a table form. So again, when your graph is horizontal, and this is only when the center is at 0, 0. Again, remember, the location of A squared, the bigger number, that tells you which way your ellipse is going to be. So since A squared is under X, that tells me it's horizontal. When A squared, and then again, this thing, we're going to keep our X and our Y squared in the same spot. What I'm going to move is A and B. So when A squared is under Y squared, then we know that it's going to be vertical. It's along the y-axis. Now, technically, addition is commutative. So really, we could see it in this format as well. But most of my examples, wherever A squared is located, the bigger number, that's going to tell you if your graph is either horizontal or vertical. And then this is the little shortcut for finding the vertices. Whenever your graph is horizontal and the bigger number is under X squared, then that A value goes in the X spot. And then the minor axis, that's going to be the shorter one. And then the B value goes in the Y spot. Focus is always the same as the vertice. So it's in the X spot. And then vice versa for the vertical. Notice when it's the vertices, if A squared is under Y squared, then that's where you put the A value. And then B was in the underneath the X, so it goes in the X spot. And then C is always the same as the vertices. We will need to use this formula to find our C value, because in the given equation, you're going to be given A squared and B squared, and then you'll have to calculate C. Now, we're going to be using this information as well here, that the length of the major axis is always equal to 2 times A. And then the length of the minor axis is going to be 2 times B. Okay, so it wants us to graph, find the vertices, co-vertices, and foci, okay, or focus points. Now, in the homework, the very first couple questions are not going to ask you to key in the co-vertices. It's just going to ask you for vertices and I think foci. So later on, it's going to ask you for more than just the vertices and focus points. It's also going to ask you for something called the eccentricity. So, and this is going to come up later on, I think on like the 9th or the 10th slide. But in the homework, WebAssign's going to ask you for this. So when you're going to enter this, this is just to find, it's called the ratio. It's going to be a ratio. And eccentricity is the lowercase letter e. And all you're going to do is take your C value and put it over your A value. Now, sometimes one of these numbers is going to be a radical. You don't need to worry about rationalizing. WebAssign will take a radical in the bottom of the fraction. So whatever you get for C and A, just put it in a fraction and type that in when it asks for this in the homework tonight. All right, so let's take a look here. Now, in order to do this, remember your equation always must equal, we need to make this a 1. And the way that we're going to do that is we're going to divide all 3 pieces of my equation by 64. And then that is now going to create my equation set equal to 1. So I now have 4x squared over 64 plus y squared over 64 equals 1. I need to simplify the fraction, that first one. So 4 over 64 is going to simplify to 1/16. This one's already simplified, and then I also simplified the 64 over 64. Now I've got it looking like what we saw in the previous slides. So remember, a squared is always the bigger number. So my a squared is located right here. So a squared equals 64, and b squared is going to equal 16. So notice my bigger number is underneath the y squared. So this tells me when it's under the y squared, I know my graph is going to be longer vertically. So this is a vertical graph. So my ellipse is looking like an oval, and it's going to be longer up and down. So now let's square root these numbers. So the square root of 64 gives me positive and negative 8. The square root of 16 gives me positive and negative 4. So now I also need to find my c value. So remember, c squared is equal to a squared minus b squared. So let me plug in my numbers. A was 64, a squared. B squared was 16. I'm going to subtract it. I get 48. I now need to square root this to get my c value. And c is equal to positive and negative square root of 48. I need to break down the radical. This will be 16 times 3. You could also do 6 times 8, but this is going to go right to my simplified radical. So c is equal to 4 square root 3. So now that I have the values of a, b, and c, now I can find my vertices. And remember, whenever it's vertical, or the bigger number is under the y, that's where I'm putting this a value. So my vertices are going to be 0, 8, 0, negative 8. My covertices, I take the b value. So for this one, it's going to be 0, plus or minus a. That's how I'm getting these. Covertices plus or minus b, 0. Because b squared's under x. So then now I'm going to put positive 4, 0, negative 4, 0. And actually in WebAssign, it's going to ask you for the smaller number first. So let me write that this way as well. So this is going to be the one you enter first. You'll enter the negative 8 first, then the positive 8, and then same thing here. You're going to enter the smaller number first. So in other words, enter the negative vertice first. And now for the focus points, this is where I'm using my c value, and it's the same spot that the vertices are. So this is going to be 0, plus and minus c. So this is going to be 0, negative 4 square root 3 and 0, positive 4 square root 3. Now, you're going to probably have to graph by hand. So you're going to have to approximate the value of the square root of 48. Square root of 48, if you think about it, it's in between the perfect squares of 6 and 7. Because the square root of 7 is 49. So it's a little bit less than the square root of 7. So I would say this is probably going to be approximately negative 6.8. And this will be approximately positive 6.8 when you're looking for this graph. So now that we found all of these pieces, and we know that there's nothing added or subtracted to the x squared and the y squared, this tells me my center is the origin. So now let me graph these 6 order pairs on my graph. So I'm just going to not use like graph paper. I'm just going to approximate this. So for, let's see, 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So again, it's vertical. So I know the ellipse is longer up and down. So here's a vertice. Here's another vertice. Co-vertice here. Co-vertice here. And then you're going to connect these. Do not do like this and make like a diamond. An ellipse is rounded edges. So just sort of add a little bend here and make it into an oval shape. And then we're going to approximate the location of these focus points. I'm going to do the focus points in pink. So 1, 2, 3, 4, 5, 6. So about there and about there. You're just approximating them. So this is where the focus is and another focus. And then right here smack in the middle, this is your center. So my center, the C, is 0, 0. These are the vertices, the V. These are the CVs. And then the focus is the F. And there's your graph. Now the eccentricity of this is the C value over the A value. So the E here, or the eccentricity, remember your C value was the square root of 48 and the A value was 8. You don't need to, WebAssign's not going to mark it wrong if you don't key it in as 4 square root 3 over 8. You can leave it as the radical, the whole thing unbroken down. All right, so for the next one, notice it's already equal to 1. I'm going to look for my bigger denominator. So my bigger denominator is 9. So A squared is 9. B squared is 5. I need to square root these. So A plus and minus 3. B plus and minus the square root of 5. We need to find C. Do C in pink. C squared equals A squared minus B squared. A squared 9, B squared 5, C squared equals 4. I can actually square root that, plus and minus 2. So now let's find our parts. So the vertices, remember the bigger number was under X, so that's why I put A. So for this one, it's going to be plus and minus A, comma 0. So it's going to be, and you're going to enter the smaller one first, so the negative 3 first, then the positive 3. And then for the co-vertices, that uses the B. And again, this one's going to be 0, comma, plus or minus B, because B's under X. B's under Y. So then here, it'll be 0, comma, negative square root 5, and 0, comma, positive square root 5. The focus points are always the same as the vertices, so plus and minus C, comma 0. So this one's going to be negative 2, comma 0, positive 2, comma 0. Now, the square root of 5, it's in between the two perfect squares of 4 and 3, so, or 3 and 4, because it's 4 and 9, 2 and, let me just write it out. So, square root of 4, square root of 9, so square root of 5 is in between, so I'm going to say it's probably about 2.2. Again, you're just approximating this. So this will probably be about negative 2.2 and positive 2.2. So now let's graph all of this. Nothing was being added or subtracted to the x squared, y squared. So I can see that my center again is going to be at 0, 0. So your center, 0, 0. I'm going to graph the vertices. Okay, so let's graph the vertices. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so my vertices are at negative 3, positive 3. My co-vertices, remember we approximated that, so a little bit more than 2. My focus points are on the same axis as my vertices. So it's right here at positive 2 comma 0, negative 2 comma 0. We need to connect my blue and red points. So again, make it in an oval shape. Don't just make it diagonal lines. And there's your ellipse. So these are vertices. The blue ones are co-vertices. And the pink ones are the foci. And then the black one right in the middle, I'll make it green. That's going to be your center point. Your eccentricity, remember, is just C over A. C was 2, A was 3. So 2/3. Okay, so now these are the formulas when the center is not at 0, 0. Now technically you can memorize it this way, but what we're going to be trying to do is keep the x squared and the y squared in the same spot. And I'll move the A and the B. But technically addition is commutative, so you could see it the same. You could see it this way, but if you memorize it this way, it makes it a little bit easier. And again, it has to be equal to 1 before you can start finding all these pieces. Now, instead of the A going right into the vertice, we have to add it to the center point. The center point is the order pair HK. And that's what's going to be added or subtracted to your X and your Y values. So let's try some examples now. So the first thing I'm going to do is make sure that my equation equals 1, which it does. The next thing I'm going to do is pull out my H and K. Remember, the HK is always going to be, H is always with X, K is always with Y. So my center, backwards of what you think, is going to be the order pair positive 2, negative 1. So this is my center. Now, A squared is always the bigger number. So A squared is 16, B squared is 9. C, I'm using the same formula, A squared minus B squared. So my A value is the square root of 16, positive and negative 4. My B value is the square root of 9, positive and negative 3. And then for the C, C squared equals 16 minus 9. C squared equals 7. So C is equal to positive and negative square root of 7. Square root of 7 is going to be maybe a little bit more than 1.5. So I'm going to say it's probably approximately 1.6 when I go to graph these. Or actually, no. Sorry, I take that back. Let me go back up here. So let's do square root of 4, square root of 9. This is 2, this is 3. So square root of 7 is going to be in between here. So it's about 2.6. Everybody good on that? For the vertices, let me change the color. Vertices, notice my 16 was under the Y. So I'm taking my center point, my HK, and I'm going to add and subtract A to the Y of the center. Because technically, the center is this, HK. But remember, an ordered pair is also XY. So I'm adding, since the 16 was under the Y, and Y is the K, I'm adding A to the K. So my center was 2. And then the K was negative 1. And then I'm going to add and subtract 4. So my two vertices are going to be 2, comma, negative 1 minus 4, 2, comma, negative 1 plus 4. So this will be negative 5. And this is going to be positive 3. These are my two vertices. For the co-vertices, I'm going to add B to the X, because that's where B was located, under the X. So for the co-vertices, I'm going to take my center point, the H, plus or minus B, comma K. Because my b squared was under x, so that's why I'm adding it to the h. So 2 plus or minus 3, comma, negative 1, 2 minus 3, negative 1, 2 plus 3, negative 1. So negative 1 is a covertice, and 5, negative 1 is the other covertice. Now we need to find the focus points. And we're going to be adding C to the same thing we did for the vertices. So we're going to add it to the K. So for the focus, H, comma, K plus or minus C. And I'm just going to leave it in radical form. So again, remember your H here was 2, negative 1 plus or minus root 7. So the two focus points, 2, comma, negative 1 minus the square root of 7, 2, comma, negative 1 plus the square root of 7 are the two focus points. So now let's graph all of this. Now that we found the two vertices, the two covertices, the two focus points, and the center, let's graph it. So again, make your coordinate plane, and let's go ahead and graph these. So 1, 2, 3, 4, 5. All right, so for my vertices, I have 1, and I need some more lines here, 3, 4, 5. I have 1 at positive 2, negative 5, and then I have 1 at positive 2, positive 3. Then my covertices, these are on the major axis. The minor axis, the endpoints of that are the covertices. So negative 1, negative 1. And then positive 5, positive 1. I'm going to also graph my center. My center was positive 2, negative 1. That's the green dot here. I'll put a dot, a black dot in the middle so you can see it a little better. This is the center. And let's get the focus points on here. And again, we're approximating these. So this is really negative 1 minus 2.6. So 2, comma, negative 3.6. And then negative 1 plus 2.6. This will be about 2, comma, 1.6. So if I go ahead and put those focus points on here, 1, 2, 3, so about here, and then a little bit more than 1, another focus point. And again, let's go ahead and connect this. Again, make it a nice oval shape. Connect the red and the blue. And notice it looks like it's a little bit longer up and down because your major axis or your bigger number was under the Y. And the eccentricity, remember, is just C over A. So it's just square root 7 over 4. Okay, so again, remember your equation needs to equal 1. So what I'm doing here is dividing. Okay, so I need to really divide all of this by 16. Divide by 16, and this is really 16 times 4. So now my new equation is going to be x plus 3 squared over 64 plus y minus 3 squared over 16 equals 1. I now need to look for my bigger number. The bigger number is 64. So a squared is 64. B squared is 16. And C is going to be a squared minus b squared. So 64 minus 16. And I get c squared equals 48. And then c is equal to plus and minus square root 48. But I'm going to break it down. 4 square root 3. Over here, this gives me positive and negative 8. This gives me positive and negative 4. Notice the bigger number is under x, so my ellipse is going to be horizontal. It's going to be longer horizontally. So I also have to pull out my center point. So my center, remember this is h, this is k. So my center, opposite of what you think, negative 3, positive 3. So now let's go ahead and find our vertices. So we're going to be adding A to the H of the center to get your vertices. So really what we're doing is H plus or minus A, comma, K, because that's where the bigger number was under. It was under the X or under the H. So I'm going to be doing negative 3. Let me just put it in. So minus 8, comma 3. And then negative 3 plus 8, comma 3. So this gives me negative 11, comma 3, and 5, comma 3. Those are your vertices. Remember the b squared was under the y. So I'm going to, for my co-vertices, I'm going to take my b value and add it and subtract it to the k. So for the co-vertices, it's going to be negative 3, comma 3 minus 4, and negative 3, 3 plus 4. So negative 3, negative 1, negative 3, positive 7. And those are your co-vertices. And now we're going to do the same thing for the focus. And it's the same as the vertices. So we're going to add and subtract C to the H of the center. So negative 3 minus 4 square root 3, comma 3. And then negative 3 plus 4 square root 3, comma 3. And you just leave it like that. We can't simplify that. However, remember we had approximated the square root of 48 back on that other problem. So when I go to graph this negative 3 minus 4 square root 3, this will be approximately negative 9.9, comma 3. And then this one will be positive 3.9, comma 3. Those are your focus points. So now let me go ahead and get these 7 ordered pairs on the graph. The center, 2 vertices, 2 co-vertices, and the focus points. So let me go ahead and make my graph here. All right, so we got to go all the way over here to negative 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 1, 2, 3. So I have a vertex here at negative 11, positive 3. And then 1, 2, 3, 4, 5. 5, positive 3. These are vertices. Co-vertices are going to be at negative 3, negative 1, and then negative 3, 7. So my co-vertices are going to be negative 3, positive 7, and negative 3, negative 1. So co-vertices. And then we approximated the focus points. So almost to 10, negative 10. So negative 10, positive 3, focus point. And then almost a 4, 1, 2, 3, 4. And then 3, another focus point. And again, connect the red and the blue dots, the vertices and the co-vertices, and make it kind of oval. Nice little bend to it. Center point was negative 3, positive 3. So there's your center. And then the eccentricity, C over A. C was 4 square root 3 over 8. And actually I can simplify this. I can make that a 1 and a 2. So square root 3 over 2. So that's your eccentricity.